Okay, I hear recording in progress, so go ahead and start. All right, so we're here, last day of September, believe it or not. So tomorrow's already October the 1st. And do 3.5. And tomorrow you get a quiz on what we're covering. I'll talk about the quiz at the end. Okay, so 3.5 is on more different kinds of functions. The topic for today is sort of something we've already tackled. I'll do several of those, but I didn't want to go too far lest I overly confuse you for the quiz. Okay, which means we may very well end sort of early today, and I still have plenty of time to knock everything off for the test next Friday, right? So our next exam is Friday the 8th, exam 3. And it'll cover this material right up here. Okay, again, for 3.5, skip problem 11 and 23 on. So I'll try to show you how to do the problems up until 9 today. And hopefully that won't be too bad, but we'll see how it goes. Okay. All right, so again, please note the change in the assignment. It's much shorter. Okay, a lot of the stuff that we had extra, it's nice math, but this is supposed to be pre-calculus. So if it's pre-calculus, I shouldn't be giving you stuff that you don't need in calculus. So let me go straight to that and show you what it is. Okay, so first, as I always do, I'll try to show you what the problems are. For those of you who don't have the book and don't plan on getting it. So the topic is other algebraic functions. So we have a whole bunch of square root kind of functions, which is what I'll focus on today. So there's 1 through 9. They're all square roots. To work them out, they all pretty much work the same way, something we've talked about before. When you have the square root of whatever, it has to be greater than or equal to 0. And that's stuff we've already tackled, right? So it should not be much of a mystery as to how to do those kind of problems. And yeah, we said skip 11. I don't want to do all this matching. And then 13 through 21, and I'll save that for next time or maybe even next week. Okay, I think it's up to 21. We said skip 23 on, right? Okay, so I didn't want you to fool with the graphs of these. The graphs of these are too difficult. So 13 through 21, these other kind of functions. So we'll talk about those next time, but not today. Okay, so today we'll handle square root functions. Okay, so here we go. So f of x equals square root of whatever. They all pretty much work the same way. When you have the square root of whatever, that thing behind my finger has to be greater than or equal to 0. So that's the basic technique for working any of these problems out. So here we go. Okay, 3.5. Problem number 3. Again, ignore any dates. F of x equals the square root of x minus 1 squared x plus 2. Okay, so we should know the way the game works. Underneath the square root has to be greater than or equal to 0. All the problems work the same way. Okay, whatever's under the square root has to be greater than or equal to 0. And then I just solve that by techniques that I've done in the past. So in some sense, this is not really even a new section. It's a review section. So if I were to give you a question like this on the quiz tomorrow, it should be hopefully straightforward. Okay, so whatever's behind my finger, there it is, greater than or equal to 0. Okay, we played that game before. So set down my boundary numbers, which are 1 and -2. So 1, -2, there they are. And I have 3 regions. Region 1, region 2, region 3. Both are closed circles. If I plug in -2 here and here, -2 plus 2 is 0. It would say 0 is greater than or equal to 0. That's true. And likewise, if I plug in 1, 1 minus 1 is 0. 0 squared is 0 times whatever that is. It will say 0 is greater than or equal to 0. That's true. Okay, so at the moment, I have a closed circle at -2. a closed circle at 1. And then I have to decide, am I shading in regions 1, 2, or 3? All right, so we know the way the game works. Pick something over here, -3. Pick something in the middle, 0. Something over here, 2. And part of which makes the calculation pretty easy, this is blah, blah, blah squared. Well, whatever I plug in, as long as it isn't 1, and I'm not plugging in 1, it'll be positive. So plus, plus, plus automatically, right? I don't have to bother plugging these in. The fact that it's squared means it's going to be positive. So I only have to look at this thing. Okay, -3 plus 2, negative. Positive times a negative, negative. Negative greater than or equal to 0, that's false, so do not shade in region 1. Region 2, 0. 0 plus 2 is positive. Positive times positive is positive. Positive greater than or equal to 0, true. Shade in region 2. And then 2. Okay, I don't have to plug in here. I already know it's positive, right? Even if this came out to be negative, I'm scoring it, so it's positive. 2 plus 2, positive. Positive times a positive, positive. Positive greater than or equal to 0, true. Shade in region 3. All right, so for these functions, we're not asked to graph it. The graph is too difficult. It just asks for the domain. All right. Now, here, even though I broke it up into 3 regions, you don't have to do the union stuff. I don't have to do the U, because it looks like I can just go straight from -2 all the way to infinity. So the domain is bracket -2 infinity. No need to go -2, 1 union, 1 infinity. You could say it much more compact by just saying, oh, I'm going from -2 to infinity, because I'm shading all of this and all of this, and even 1 I'm including. So bracket -2 infinity is good enough. Okay. So in other words, why use the union thing, the U for union, when it's not necessary? Okay. Now, for something like number 5, it looks like there is going to be a U for union because it's broken up into different pieces. All right, so this one, region 2 got shaded, region 3 got shaded, region 1 did not get shaded. So I have all of this. All right, so that's the way it works. Seen this before. Do another one like that where it's only a product. And then 7 has a quotient, has a fraction. We've worked with that before. And 9 also has a fraction. Okay, so I'll show you those. And then that was pretty much all I was going to do today, folks. I was going to be finished after I'm done with 9, at which point you can either ask me questions about this or any other section, or we're just going to dismiss fairly early today. All right, number 5. F of x equals x plus 1, x minus 3, x plus 4. Okay, so no matter what kind of junk they put underneath the square root, right? Everything underneath the square root has to be greater than or equal to 0 in order for me to get the square root. I can't take the square root of a negative for real numbers. We can for complex numbers. In fact, our last section before the test, 3.6, we're back to doing polynomial long division again, but with complex numbers, the a plus bi stuff. But for 5, blah, blah, blah has to be greater than or equal to 0. So square root of x plus 1, x minus 3, x plus 4. That expression, x plus 1, x minus 3, x plus 4, has to be greater than or equal to 0. So I set my boundary numbers. That's easy. What makes this 0? What makes this 0? What makes this 0? -1, 3, -4. Yes, it is a shortcut to essentially just change the sign of each of these. You know, that's a +1, so make it -1, right? That's a -3, so make it a +3. That's a +4, so make that a -4. But really, algebraically, what you're saying is, what number do I plug in to make this 0? -1. What number do I plug in to make this 0? 3. What number do I plug in to make this 0? -4. Okay, because if I plug in, let's say 3 here, here, and here, well, this middle 3 minus 3 is 0, so you don't care what these come out to be when you multiply them, it's still going to be 0. 0 is greater than or equal to 0, true. So closed circle, closed circle, closed circle. They're all going to be true. They're all, if I plug in -1 or 3 or 4 or -4, they're all going to say 0 is greater than or equal to 0. So closed circle, closed circle, closed circle. If I had it like this, you might recall, they would all be open circles. All right, so same thing, we've played this game before. So 3 boundary points, 4 regions, 1, 2, 3, 4. So pick something to the left of -4, like -5. Something between -4 and -1, well, -2. You can pick -3. Something between -1 and 3, 0. You could pick 1, you could pick 2. I mean, you can pick 1.3165214148828 if you wish, but you know, I like nice stuff. And bigger than 3, 4. You could put pi, but that's too much work. Plug it in. I only need a sign. It's a lot easier. Okay, -5 plus 1, negative. -5 minus 3, negative. -5 plus 4, negative. So negative times negative times negative. 3 negatives leaves you with a negative. Is negative greater than or equal to 0? No, that's false. So don't shade in region 1. Okay, -2. -2 plus 1, negative. -2 minus 3, negative. Whoops. -2 plus 4, positive. So 2 negatives and a positive multiplied together, positive. Positive greater than or equal to 0, that's true. Shade in region 2. Region 3, I decided on 0. So 0 plus 1, positive. 0 minus 3, negative. 0 plus 4, positive. So what's a positive times a negative times a positive? Negative. Negative greater than or equal to 0? No, that's false. Do not shade in region 3. And finally, region 4. 4. You can put 5. You can put 80. You can put 1,000,000. But I'll pick 4. 4 plus 1. Oh, it looks like they're all positive. Let's check they're all positive. 4 plus 1, positive. 4 minus 3, positive. 4 plus 4, positive. So positive times positive times positive, positive. Positive greater than or equal to 0, that's true. Shade in region 4. And yes, this time I'm forced to use the union because I had 2 pieces. Now over here, I didn't have to write the union because I am able to write the whole thing just as one interval because this was a false region, this was a true region, this was also a true region. So instead of saying -2, 1, union 1 to infinity, I might as well just say from -2 to infinity, right? Here you have no choice because there's 2 separate pieces. I have to do the union thing. So bracket -4, -1 bracket, union bracket 3 to infinity. Remember, infinity and negative infinity always have parentheses. Negative infinity is always on the left side. Positive infinity is always on the right side. And they always have parentheses because you never reach infinity. You never reach negative infinity, so to speak. Okay. All right. So that was number 3 and number 5, which only involve products. And then I was going to show you 7 and 9. And you know, you might be saying, hey, these problems are right off the homework. That's right. So every one I'm doing is a little bit less you have to do, right? So again, when I say you have to show me at least 70% of the homework, that's kind of a joke. I do a huge percentage of the homework anyway, in which case you just have to copy it and do the rest of the problems, right? Okay, I was going to show you 7 and 9 because they're quotients, something divided by something. Okay, but you still do the same thing. It's blah, 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 greater than or equal to 0. Right? So f of x equals whatever. So whatever's behind my finger, 1 minus x over x plus 3, greater than or equal to 0. And you work it out very similar fashion to the product ones. The thing you have to watch out for is you're not dividing by 0, right? We have to make sure we're not dividing by 0. So my boundary numbers set the top and the bottom equal to 0, right? What number makes the top 0? What number makes the bottom 0? So set the top and the bottom equal to 0. You're welcome to put that little algorithm on your cheat sheet if you wish, right? You say, oh, I forgot what to do here. Set the top equal to 0, set the bottom equal to 0. So top equals 0 means x equals 1, right? Set the bottom equal to 0, x is -3. So -3 and 1. Now, how come one of them is open and one of them is closed? Well, if you plug in 1, put a 1 here and a 1 here. 1 minus 1 is 0. 0 divided by that is 0. It will say 0 is greater than or equal to 0. That's true. Shade that in. However, what happens if I plug in -3 here and here? Well, right here, I say, oh, -3 plus 3 is 0. I'm dividing by 0. That's automatically a mathematical no-no. So that is left open. Okay, so when you have quotients like this, quite often you'll have open circles, or some open and some closed. So -3 doesn't work. 1 does work. So at this stage of the game, you just have this, trying to cover this up. That, and that. You can tell 1's going to work. Plug in 1. 1 minus 1 is 0. 0 divided by that is 0. The inequality says 0 is greater than or equal to 0. That's true. But if I plug in -3 right here, I'm dividing by 0. So that kind of wipes out the rest of the problem. Isn't going to work. Okay, region 1, 2, 3. So region 1, -4. Region 2, 0. Region 3, 3. I picked 3. I don't know why I picked 3. Maybe because I thought it was region 3. You could pick 2 or 3 or 4 or a million, but anything on this side. You plug in -4. 1, got to be careful. 1 minus a -4. 1 plus 4 is positive. -4 plus 3 is -1. That's a negative. So I have a positive divided by negative, which is negative. Okay, is a negative greater than or equal to 0? No, that's false. Do not shade in region 1. Now, region 2 got shaded in. How come? So 0. 1 minus 0, 1, positive. 1 plus 3, positive. Positive divided by positive, positive. Positive greater than or equal to 0, that's true. Shade in region 2. And it looks like in the final analysis, we did not shade in region 3, so let's see why. So I plug in 3. 1 minus 3, -2, negative. 3 plus 3, positive. So I have a negative divided by positive, which is negative. Is a negative greater than or equal to 0? No, that's false. So I don't shade in region 3. So I just have this, which is parenthesis, -3, comma 1 bracket. And that's my domain. Means do not include -3, include 1, and then everything in between. All right. All right, then I was going to show you number 9. Let's see, it's only a little bit past 9:30 or about 9:30. So we'll be done fairly early, I think, unless you have a question. So all I have left was 9, although this is going to take a little bit longer, I can tell. And then I'll make some remarks about the quiz. And then if anybody has a question, you can ask it. Otherwise, we'll be done fairly early today, I think. Okay, square root of blah, 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 whatever, the blah, 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 whatever's behind my finger, greater than or equal to 0. Oh, and yes, factor the denominator. So x squared plus 2x minus 3, 1 and 3, right? So x plus 3, x minus 1 by factorization. Is that right? You can check by formula back out, right? X squared minus 1x plus 3x is a plus 2x, and then minus 3. All right, so in factor form, this entire expression has to be greater than or equal to 0. So there it is, x plus 1 over x plus 3, x minus 1, greater than or equal to 0. So it's a little bit longer just because there's 3 boundary points. 3 boundary points means 4 regions, right? So what are my boundaries? set the top and the bottom equal to 0. Okay. Put this in your cheat sheet if you wish. All right, so how do I make the top 0? -1. How do I make the bottom 0? With either a -3 or a +1, right? So -1, -3, and +1 are my boundary numbers. How come I got open, close, open? If I plug in -3 right there, that gives me 0. 0 times that is 0. I'm multiplying by 0. Oh, sorry, I'm dividing by 0. Can't do it. Open circle. Similarly, if I plug in 1 here, here, and here, 1 minus 1 is 0. 0 times that is 0. Can't do it. Cannot divide by 0. Open circle. But how come -1 is closed? If I plug in -1 here, here, and here, I notice, oh, I have -1 plus 1, which is 0 in the numerator. You're allowed to have 0 in the numerator and then divide it by this, as long as the denominator is non-zero, the ratio is 0. So the inequality will say 0 is greater than or equal to 0. That's a true statement. So this one gets colored in. So open, close, open. I'm allowed to have 0 on top. -1 gives me 0 on top. But -3 and 1 gives me a 0 on the bottom. That's never allowed. All right, then I just do the same thing. It's a little bit longer because I have 4 regions. So at the start, at least, I don't know which region to shade in. Let's just pick something over here like -4. Something here is like -2, 0, and 2. Do my sign chart. -4. -4 plus 1, negative. -4 plus 3, negative. -4 minus 1, they're all negative. 3 negatives, when you multiply and divide, you end up with a negative. Negative greater than or equal to 0, no, that's false. Don't shade in region 1. Region 2, -2. -2 plus 1, negative. -2 plus 3, positive. -2 minus 1, negative. So what's a negative divided by a positive times a negative? There's 2 negatives. So the whole thing is positive. Positive greater than or equal to 0, that's true. Shade in region 2. Region 3, 0. 0 plus 1, positive. 0 plus 3, positive. 0 minus 1, negative. Positive divided by positive times a negative, there's 1 negative, so the whole thing is negative. Negative greater than or equal to 0, that's false, so do not shade in region 3. And finally, region 4, 2. Looks like they're all positive. Let's check. 2 plus 1, positive. 2 plus 3, positive. 2 minus 1, positive. So if you only multiply and divide positives, you've got a positive. Positive greater than or equal to 0, that's true. Shade in region 4. So here's my domain. So parenthesis, -3, comma, -1, bracket because I'm including the -1. Union, parenthesis, right? Parenthesis 1, comma, and then I shade all the way to the right. So infinity on this side. So that pretty much does it for that. All right, so that's as much of the lecture I was going to do today, folks. I'm going to talk a little bit about the quiz now, and then I'll take any questions. So the quiz tomorrow, I'll give you something like what we just did. Okay, so I'll give you something like this. Say, find a domain of square root of blah, 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 blah. Work it out exactly like, you know, how I did any of this. And then I was also going to give you one of these rational functions. Okay, so that's a mean trick. I know it's a little bit harder, but I want you to get a feel of how to do this kind of stuff. Okay, so quiz tomorrow. Check our calendar again. Where are we? So tomorrow is already the 1st of October. Okay, buffer day doesn't mean holiday, as you've heard me say that. I'll just keep going with 3.5. So I will give you a rational function where you have to graph it, maybe give you something like this. Say, what's the horizontal asymptotes? What's the vertical asymptotes, right? Maybe what's the domain? What's the intercepts? And a quick sketch of the function. So consider domain, intercepts, va and ha, vertical asymptote, horizontal asymptote, and maybe just a quick sketch. And then I'll also ask you stuff like we just did, right? So find the domain of a square root business. Oops. So they're all the same. Just whatever's behind my finger, make that greater than or equal to 0, and then do the sign analysis. Okay, so that's problems 1 through 9. What else is there in this section? How do you graph stuff like this? So sketch the graph, label the axis, intercepts, and asymptotes. So we'll talk about having rational exponents. Okay. But all the other stuff looks like stuff we've done before. You know, subtract 2, add 1, parentheses. That just moves the graph left, right, up, and down. So we see that similar theme occurring once more. Okay, so I'll tackle that starting tomorrow. Okay, but otherwise I'm done, folks. So if anybody wants to ask a question, you may. I can't see the chat right now, so let me double check anything's in the chat. Okay, so 3.427. Okay, let's see what that's about. I just realized okay. 3.427. F of x equals x squared minus x minus 2 over x squared minus 2x minus 3. Double check that I wrote it correctly. I think so. Okay, and that's how I see in the chat. Okay, so let me try that. And if you want to, anybody else wants to put something else in the chat, you may. I normally can't see the chat when I'm switching the screen. Shared screens. All right, so maybe I'll first try to factor this thing. Paren, x, 1, 2, and minus plus. Right? x, 1, 3 plus minus. Okay, so this one's going to have a hold, right? So this cancels out to x minus 2 over x minus 3, provided that x is not equal to -1. Right? So again, we had this kind of question on the test, right? If I say, what's the difference between this function and this function? Here, -1 is allowed. Here, -1 is not allowed. So x equals -1 is not going to be a va, vertical asymptote. It's just going to be a hole. So what do I get if I plug in -1? Let's see. -3 over -4. So -1 3/4 is going to be a hole in the graph. So I just analyze this. So vertical asymptote, x equals 3. Horizontal asymptote, first degree, or I could go back to this, but as long as I got an easier one, I want to take the easier one. Just look at the leading coefficients, 1x divided by 1x, y equals 1. And yes, let's get intercepts. X is 0. X is 0, I get what? -2 divided by, whoops, -2 divided by -3, 2/3. And how about y equals 0? When is the fraction equal to 0? Top is 0, so 2. All right, so let's start graphing what we have. Okay, ha, horizontal asymptote, y equals 1. Va, x equals 3. X equals 3. Oops. I have 0, 2/3, which is lower than here. So, and 2, 0. I mean, this itself kind of tells you it's probably going to go like that and go like that, right? Let's double check this. So end behavior, for sure, we're going out over here. I'll go like that. Although technically it is possible for the graph to pass up and then come back down, but this is the easiest. And likewise over here, I go out toward y equals 1 in the infinite sense. And let's see what happens if I'm near 3. So x approaches 3 from the left, x approaches 3 from the right. The expression is x minus 2 over x minus 3. I'm just rewriting it so we can see it. Okay, a little bit to the left, 2.9. Positive, negative. So negative. So y approaches negative infinity. So just as we suspected, it goes like that. X approaches 3 from the right, 3.1. 3.1 minus 2. 3.1 minus 3. Positive. Positive divided by positive. Positive. Y approaches infinity. So when I get real close to 3 coming from the right side, I shoot up toward positive infinity. And then end behavior, when x gets really, really big, the graph gets close to y equals 1. So here's my graph. And then the last thing I got to do is go back and remember to punch a hole at negative 1, 3/4. So there's negative 1, 3/4. Here is 0, 2/3. Here is 2, 0. And so that seems to be the entire graph. I got a hole in the graph. So these two graphs are identical, except at x equals negative 1. This one, the original one has a hole. This one does not have a hole. It just plugs up the hole, so to speak. And there we go. Let me show you this again. Oh, let me just go back and show you the whole thing in case you need it. That and the graph. And that. Okay. Check the chat again. I don't see anything else in the chat for now. Okay. Any other questions, please? Otherwise, we're done for the day. You can either unmute yourself. Professor. Okay. All right. Okay. Anybody else, please? All right. Have a good day, everybody. See you next time.
You too.
Bye. Thank you. Bye.